All right, we've made it to classifying polygons, and we've definitely seen these shapes before, but formally, a polygon is a closed plane figure, and a plane figure is just something that lies in a plane, if you guys remember from chapter 1, so it's like a 2D figure, and it has the following properties. So the first is it's formed by 3 or more line segments, and these are called the sides of a polygon. So this would be side AB over here that I just wrote, and then all the way around we'd have side B, C, C, D, D, E, A, E, all those sides. This is a 1, 2, 3, 4, 5-sided figure. So this would be considered a polygon. Notice that these are line segments, so my writing's going a little fast here. This would not be a polygon down here since I've got this arc shape. This is not a line segment. Also for polygons, each side intersects exactly 2 sides, one at each endpoint. So no sides with common endpoints are collinear. So we wouldn't want any sides to be on the same side. We don't have like endpoints in the middle of sides. We've kind of seen polygons before, so nothing strange should really look like it's going on. So just like we have been naming triangles and angles, we can also name polygons, and we name them using the vertices, or one vertex would be called a vertex. So this polygon can be named, we could do A, B, C, D, E, or we could change up the order, C, D, A, B, any order where the vertices are staying in order. So I do need to go like around the polygon. I couldn't jump from vertex C to E to B to D. I need to go around the polygon in order. We also have kind of 2 different ways to describe polygons. So we have a convex polygon, where if we drew lines on the sides, they wouldn't go into the interior. So what I just highlighted in pink here is the interior of the polygon. And if I drew lines on the sides, on the outside of the polygon, so if I drew a line over here, right, that wasn't a good line for my first one, but all these lines would never go into the interior of my polygon. Again, that first one was bad, but they all stay on the outside. Versus this second polygon over here, highlighting the interior in this light yellow, if I drew a line on this side over here, it crosses into the interior. So this guy we call concave. I think about it like it's caving in on itself. And if those lines don't go inside, we call it a convex polygon. Okay, we are probably pretty familiar with many types of polygons, but we classify them by the number of sides they have. So if the shape has 3 sides, we have heard this before, it is a triangle. That prefix tri is 3. 4 sides, we've heard that before, that is a quadrilateral. And that prefix quad is for 4. So on and so forth. 5 sides is a pentagon. Penta is 5. 6 sides is a hexagon. Hexa, right, is our prefix for 6. 7 sides is a heptagon. 8 sides, like a stop sign, is an octagon. And then I got a little lazy drawing. 9 sides would be a nonagon. 10 sides would be a decagon. And pretty much the most that will go is 12 sides is a dodecagon. But these aren't the only ones out there. You guys can Google, and there's other names for other shapes with certain number of sides. But for any number of shape, we would put the prefix in front and then add gon on the end of it. So you guys see pentagon, hexagon, heptagon, right? Triangle and quadrilateral, a little bit different, but that's our basic concept. Okay, finally to wrap up here, we can use some of these familiar terms that we've had for like triangles to also describe any of our polygons. So an equilateral polygon would have all sides congruent. An equiangular polygon would have all angles congruent. And if we call it a regular polygon, that means all of the sides and the angles are congruent. So I drew over here on the right side a regular pentagon that I just kind of highlighted over the name because it has 5 sides and they all are congruent along with all of the angles. So that's it for our intro on polygons. Hopefully made sense for you guys.